Hi everyone, I'm Ronald Andrew. I'm currently doing my bachelor's in mechanical engineering. Today, I'm going to do my individual assignment for the subject MPU3422. So today, I'll be talking about the internal combustion engines, their uses, and the differences between turbopropeller engines and turbofans.
If you think propeller aircraft are a thing of the past, think again and look at the private jet aviation, even if most people like to label the entire segment as private jets. Last year, on demand and jet charter flight for turboprops increased 8% versus 4.9% for jet flights. Today, my speech will be covering about the turbopropeller engine, the thrust generation, and the comparison between turbofan. Well, there are four different types of gas turbine engines: turbojet, turbofan, turboprop, and turboshaft, and each works on its own principle. Well, one may ask what force pushes the aircraft forward and upward. Isaac Newton has already stated this in his second and third law. Thrust is generated when the air is pushed out of the engine, and in order to balance for that momentum of this air, the engine and with the aircraft is pushed in the opposite direction, which is forward. It's like a jetpack for astronauts, which makes them move up even though the jet itself is going downward. Thrust equals to the mass of air entering the engine multiplies the acceleration. Well, let's see how does the turbofan engine works with the principle of thrust. A small mass or quantity of air enters the engine, which is accelerated to a much higher value inside the engine, causing an increase in the thrust force. The thrust can be increased by increasing the acceleration of air. In turboprop aircrafts, we have a propeller which creates the thrust. Here, a large quantity of air or a mass of air is accelerated by a small value which causes an increase in the thrust force. However, there is a limitation on the mass of air being accelerated, so it produces a lesser thrust. Turbopropeller engine consists of two major sections, an engine core and a propeller. This is a schematic diagram of the engine core. Each compartment has its own role to play together. The engine core consists of compressor, which is used to compress the air or to increase the pressure and temperature to the air. Increase the pressure or a temperature of the air before they are sent to combustion. Combustors, which consist of fuel nozzles, igniters, and combustion chamber. Here, fuel is sprayed with which mixes with the high pressure air and gets burned inside the combustion chamber. Thus, the air becomes even hotter and even more pressurized. In the combustion chamber, the pressure and the temperature of the gas increases. The high pressure gases are then allowed to expand in the turbine section, which causes the turbine to rotate. Thus, this causes the compressor to rotate. These components are like gas-like turbines. There is an additional turbine on the turboprop engine called drive turbine. Here, the gases expand further, causing a decrease in the pressure and the rotation of the turbine. This turbine extracts almost all the pressure energy from the incoming gases, so very little thrust is generated at the exhaust. Jet engines normally rotates at a speed of 20 to 25,000 rpm, so it cannot be connected directly to the propeller because the tip of propeller, which will reach a supersonic speed and produces micro shock waves to the tip of which causes the blades to stall. So the turbine is connected to a reduction gearbox to reduce the speed of the shaft, so the propeller works more efficiently. The second compartment, this is a simple mechanism on how to turboprop engine works. The second compartment of propeller section of turboprop engines is the propeller sections, which consists of a series of airflow shaped plates connected to a hub and assembled on a shaft coming from a reduction gearbox. In a modern turboprop aircraft, the blade angles will vary depending on the throttle setting. There are different blade angles for different settings such as ground idle, feather, power, flight title, and reverse. Now, let's see how the thrust force created on engine as the drive turbine rotates. It extracts most of the energy from the high pressure gases to rotate the drive turbine. So very little thrust is created at the exhaust. The drive turbine rotates the propeller, which creates most of the thrust force on the aircraft. Approximately 80% of the total thrust is created by the propellers and 20% of the thrust is created by the exhaust gases. The thrust created by turboprop is lesser than turbofan engines, so the aircraft which are slower aircrafts with turboprop engine can take off and land on a smaller runway. Biggest advantage of the turboprop is that fuel consumption is much less when operated on shorter routes compared to turbofan engines, which needs higher consumption of fuel. This means less operating costs for the company. So the turboprop aircrafts can be found smaller, short-range aircraft at the most efficient of these operations. Moreover, the maintenance cost is also lesser for turbopropeller engines compared to the turbofan engines. Thank you.